Let me ask you something. What if menopause, the thing most of us think about happening in our 50s, actually started at age 30, or even in your 20s? Well, for millions of women, that's not some hypothetical question. It's their reality.
And that startling question leads us straight to this number, 3.7%. That's how many women worldwide are estimated to experience something called premature ovarian insufficiency, or POI, before they even hit 40. Yeah, it's way more common than you'd think.
So that's what we're doing today. We are decoding POI. We're going to break down the science, take a look at what it is, what the long-term impacts are, where it comes from genetically, and what the future of treatment might look like.
Okay, first things first. It is absolutely crucial to understand what POI is not. You'll hear people throw around the term early menopause, but from a scientific standpoint, that's just not the whole picture.
So what is it then? Clinically, POI is a disorder of insufficient ovarian function before age 40. And that word insufficiency is everything. We're not talking about a complete final shutdown here. It's more of a problem with how the ovarian follicles, those are the tiny sacs that hold the eggs, are actually working.
And this quote from a really important paper says it all. It just states it plain and simple. This is not an early menopause. And the reason for that is that the biology behind it is just fundamentally different.
And this little comparison really shows you why. So on one side, you've got natural menopause. That's when the ovaries they run out of follicles. It's a natural endpoint. But with POI, you're looking at a true hormone deficiency in a young woman. And here's the kicker. Ovarian function can be intermittent. It can come and go. The ovaries haven't packed it in for good. They're just completely unpredictable. And that difference? It's critical for everything that follows.
Which leads us right here. Why does this matter so much, beyond the obvious impact on fertility? Well, losing those ovarian hormones at a young age has really serious consequences for a woman's health long-term.
Here's the thing you have to remember. Young women are supposed to have decades of exposure to hormones like estrogen. Estrogen acts like this natural protective shield for their bones, their heart, and even their brain. So when that shield is taken away way too early, you're left with a hormone deficiency that puts the entire body at risk.
This slide really lays out the big ones. We're talking about a huge jump in the risk for osteoporosis because estrogen is just vital for bone density. There's also a higher risk of heart disease and potential effects on cognitive health. And if it's left unmanaged, this hormone deficiency is even linked to earlier mortality. It's serious stuff.
So this all brings up a massive question, right? Why? Why does this even happen? Well, let's dive into the genetic blueprint and see how science is starting to unravel the why behind POI.
It turns out, research shows that POI has a really strong genetic link. In fact, scientists have already found over 50 different genes where a mutation can lead to this condition. So it's not just one thing going wrong, it's a super complex and varied genetic puzzle.
Okay, so you hear a number like over 50 genes, and the pretty natural question comes to mind. What are all these genes actually doing? How can one tiny mutation in any of them cause the whole system to go haywire?
This table does a great job of simplifying it. You can basically group all those genes into a few key categories. So think of some of them as the biological repair crew, the ones that handle DNA repair. If they mess up, the fragile egg cells can't survive. Then you have the communication network for hormone signals. If that breaks down, the follicles never get the message to grow. There's also the ovarian life support system itself, which directly controls follicle development. And finally, the cellular powerhouse, the mitochondria, which provides the huge amount of energy the ovaries need to function. A problem in any one of these areas can throw the whole system off balance.
So, knowing the causes and the risks, the next question is, how do you manage it? Well, the main focus is on restoring that balance that's been lost.
The goal here isn't just to treat symptoms. It's about true physiological replacement. It's about restoring those missing hormones to the exact level a healthy young woman's body would be making on its own. That's the key to protecting her long-term health. Now this brings us to the two main treatment options, and they have some really important differences. On one side, you have hormone replacement therapy, or HRT, which uses body-identical estradiol. On the other, you've got birth control pills, which use a much more potent synthetic type of estrogen. And for women with POI, studies show that the gentler, physiological HRT is actually better at improving bone density and is linked to a better cardiovascular profile, like lower blood pressure, compared to the high-dose hormones in the pill. And this quote really sums up the modern thinking on this. HRT is the recommended path because its whole purpose is to replace exactly what the body is missing in a way that just mimics nature. It's all about getting back to normal physiology.
So let's finish up by looking ahead. Because beyond just managing health with hormones, cutting-edge science is exploring some amazing new frontiers for preserving and maybe even restoring fertility.
For so many women with POI, that diagnosis can feel like the end of the road for their fertility journey. But there's this wave of new research that's offering some real hope, moving away from just managing the condition to actively trying to reverse some of its effects.
And here's just a little glimpse of what's on the horizon. We're talking about techniques like freezing ovarian tissue to use later, or something called in vitro activation, which is an attempt to wake up dormant follicles in the lab. There's also research into ovarian rejuvenation, using a patient's own platelet-rich plasma, or PRP. Even stem cell therapies are being explored. Now, a lot of this is still experimental for sure, but it represents a huge shift in what we thought was possible.
And all of this leaves us with one last, really powerful question. We started by trying to understand the genetic chaos behind POI. We've seen how we can manage its effects. But what if, as we get better and better at reading that genetic code, could we one day move beyond just treatment and actually get to prevention? That, right there, is the ultimate hope.